Hello everyone, good morning. Welcome to this Kubernetes session. So yesterday we have talked about this deployment, and if you create deployment internally, that is going to create a replica set, and internally a replica set is going to create pods. So the deployment resource within this Kubernetes is greatly used for deploying the application, for upgrading the application and rolling back as well. Okay, so yesterday we have seen everything about this, whatever we have discussed till now, and there are two strategies over here. In case of the deployment, one is like rolling update, and second is like recreate. So rolling update is like it is high available. I meant to say like one pod will get created in the new replica set while upgrade, and the a single pod will get deleted from the previous replica set. So likewise a migration will happen, so all the pods in the new replica set will be up and running, and all the pods in the old replica set will get deleted. Okay, so that's how you can say a upgrade will happen internally. So if you have very critical environment like production environment, so that time you should make use of the rolling update, as it is having the high availability and zero downtime. But it is quite slow if you have a lot many number of the pods. And then we have recreate strategy in which like everything will get deleted from old and everything will be up and running in the new replica set at a time, not one by one. So this is quite fast, and but this have one drawback, that there will be some downtime till the time the pods will be up and running in the new replica set. So if we have development environment, testing environment, which is not much critical in aspect of the downtime, in that case definitely go with recreate strategy. So this looks good. Now what if, let's say if I have this replica set and everything looks good, and internally that replica set have created, let's say, two pods, and on top of these two pods, okay, let's say this pod got created via deployment, let's consider that. Okay, so I'll directly say this is the deployment, and deployment internally will create replica set, and these are pods, let's say front end pods. Okay, and on top of this, let's say I have created a service. Let's say this is my node port service, and let's say if I try to access to this node port service, okay, then internally request will get redirected to this pod, means first or second pod. Okay, so the 50% request will be handled by the first pod, and next 50% will be handled by the second pod. So this is how things will work. But let's say this pod is capable of handling 10 requests per second, same case for this 10 requests per second. But what if we got 100 requests per second to this to this service? So if we got 100 over here, let's say, then definitely these two pods will not be able to reply to all those requests properly, because the capacity of this pod, let's consider as 10 requests per second, so they will be able to handle 20 requests per second combining. So how about a rest of the 80 requests per second? Okay, so if the number of requests goes up, and if we don't have that many number of pods to handle the request, okay, so in that case definitely we will be needing some extra pods over here to handle the extra request. Okay, so we may have to create 6 to 7 or 10 pods total to handle all those extra requests, right? So this is the manual way of doing the things, like creating the extra replica for that pod. So when you will do it manually, whenever you will observe the number of requests are getting higher and higher, but there should be a single person who will be doing the monitoring task, right? If a person notice that the number of requests are getting increasing, then only that person will create the extra pods, otherwise it will not. Okay, but as we are talking about the, I meant to say some automation related things, so here as well Kubernetes have provided some automation. Okay, so whenever the number of requests will go beyond the limit, and let's say this to this pod I have given 20 millicore of the CPU, same to this pod as well, 20 millicore of the CPU, and let's say this pod is using each and everything about 20 CPU, and there, and I mean to say like 100% of the CPU is getting utilized by this pod. In that case, definitely this pod will not be able to handle the extra request because entire CPU is utilized by the previous. So that's where we can have a notification or have a threshold that if my CPU utilization of these pods goes above 70% or goes above 60%, in that case generate a new pod automatically. Okay, so if the CPU average CPU utilization of these two pods goes, let's consider 70%, create one more pod, then this pod will also handle the request from this service. Okay, again we will calculate, I means internally Kubernetes will calculate what is the average CPU utilization percentage. If again it is beyond 70%, again add one pod. So it will keep on adding the pod till the time the average CPU utilization of all the pods remains below 70%. Okay, here we are considering 70% as threshold, but it's up to us how much threshold we are expecting or how much threshold we are setting over here. So these things will be much more clear with the practical, that how extra pods will get created automatically. Okay, but let's understand the theoretical aspect of this first. Then you will, then automatically request will get redirected to this pod as well and this pod as well over here. Okay, so there will be a proper load balancing over here which is going to serve the request. Now let's say big billion days over, so total number of requests that we were getting, that is over now. So now there is a average or daily traffic which is handled by two pods. So these two pods are taking some resources definitely, and we don't want to keep our resources idle. Okay, because if we are getting very less request and we are okay to handle all those requests with these two pods, then why to keep those two extra pods? Okay, these two extra pods automatically, if Kubernetes find it out that the CPU utilization goes below 70%, then it is going to delete these extra pods. Okay, so it all depends upon the monitoring, and internally there should be some server or there should be some resource who should monitor the CPU utilization of these pods. For that matter, we don't have to worry about building everything from scratch. Kubernetes have provided metric server. This metric server is going to monitor the CPU utilization or RAM utilization of all these pods every second. Okay, so we will be installing the metric server on our end, and that metric server will definitely monitor the CPU utilization of all these pods. So how to install this? Definitely we will get an information from internet. This is something like which we don't have to write the code for, because this code will be similar for everyone if they want to have some monitoring server over here. So that's where we are directly going to install or directly going to create resources for this metric server. And once you are ready with that, then this server is going to monitor the CPU utilization. If I talk about this, let's say which all things we have, let's create a deployment. Let me create a file, new file. Okay, so this is the code which you already aware of, that we are creating deployment over here. Name of the deployment is, let's say, my first deployment with one pod only, and that pod will get created from this image, and the container name will be C1. So let's do this. So we have created a deployment. If I say kubectl top pod, sorry, top command over here is going to check for the CPU utilization of all these pods. So as of now I have a single pod over here. So if you want to check how much CPU that pod is consuming, we can check it with the help of metric server. So that's with the help of top command. Okay, and for this top command, metrics API not available. So to fix this issue, we have to install the metrics server at our end. How to install metrics server? You can just go on the internet, install metrics server Kubernetes on DigitalOcean. You will get this first link, Kubernetes metrics server over the DigitalOcean. Click on that, and this is some extra information they have provided. Metrics server is mainly for monitoring the resource utilization. Okay, so right now we have this package with version 063 and with this licensing. Just click on this 063 and you will get to see the installation guide over here. Okay, so this is the YAML file in which code is written to install the metric server. If I show you this code over the internet, okay, so this YAML got downloaded. It's nothing but a service account is getting created. This is also one of the resource that we will talk about later. Cluster role is going to get created, then we have one more cluster role binding, cluster role binding. So lot many resources are created over here. We know the service. Okay, so internally this is going to create a service as well, uh, and this service will be the cluster IP service. Then internally it is going to create a deployment. So certain you don't have to change anything over here. You directly have to go ahead and apply this file. Okay, so let me copy the, you can directly copy this content and create a file, or instead of doing that, simply you can directly go ahead and execute this command. That is also okay. So whatever the resources that we have written or that is provided by this Kubernetes within this components.yaml file, that will get executed one by one. Okay, so let's copy paste this, let's apply this file components.yaml. So internally it has created the service account then cluster role, one more cluster role banding, cluster role banding, services, deployment. Okay, so these many objects or these many resources it has created. We don't have to worry about it because this is something provided by the Kubernetes to install this metric server. Okay, and once we are done with installation of the metric server, in that case, let's check for the pod of the metric server if it is up and running or not. Okay, this will get installed under the namespace kube system. Okay, what exactly this kube system namespace is, you can skip, you can let's not have understanding of this right now. Why I have added this, because whenever we will be learning the namespace topic, that time I'll cover this topic in detail, but right now if I explain, things will not be much clear. So the metric server that we have installed is over here. So you can see a metric server pod is up and running from 41 seconds. Okay, so we are interested in this pod right now. So once this pod will be up and running, it means this pod is now ready to monitor the CPU utilization of other pods. That is what I'm trying to say. Let's say kubectl top pods. Similarly, we can check the as there is a single pod in the default namespace that we have created via deployment, and this is not utilizing any of the CPU right now. What about nodes? How much CPU they are utilizing? So only 1% utilized by this, I meant to say first worker node, 4% utilized by the second worker node. So just focus on the CPU utilization right now because that is something that we are interested into. Now, okay, I hope this much is clear till now. Let me explain one more funda over here, that if you don't provide any resources to the pod, resources means CPU and RAM, let's consider. Okay, let's say within this my dev file, this is the deployment file that we have executed, and within this I'm not providing anything related to the resources, like how much CPU this pod should use, how much RAM this pod should use. I'm not defining anything over here. I'm not setting a limit as well that this pod should use maximum 40 millicore, this pod should use maximum 30 millicore. That kind of setting I'm not doing over here. In that case, this pod will make use of the all the resources available on this worker node. Let's say this got shifted to the worker node 1, and worker node 1 having 2 CPU. Then if you are not specifying the resources over here, then by default this pod can consume all the resources available on that worker node, which is not a good thing, because if a single pod is consuming everything on that worker node, then there will be nothing left for the second pod on that worker node. Okay, second pod will not get created on that worker node in that case, because each and every pod requires certain CPU, certain RAM to get it created. So if first pod is consuming everything 100% of the resources, then definitely second pod will not be able to create on that server, or will not be able to create on that worker node. So that's where we have to restrict pods with certain resource limitation. Like, okay, let me show you the code for that, then things will be much more clear. Okay, so only thing, I have added this extra code within this file, rest of the thing is same. What is the meaning of this resource limits request? Okay, so we are providing the resources to this pod now. Okay, whenever a pod will get created, that pod will get created with 20 millicore of the CPU. And if the request, or if this pod will get more requests from the service, then definitely 20 millicore will get exhausted. Then it can go to 25 millicore, it can go to 30 millicore, because in the limit section I have specified 30 millicore. So maximum this pod can utilize is 30 millicore. Okay, whenever pod will get created, that time 20 millicore will get allocated to this pod. But if that 20 millicore is not sufficient to handle extra requests, so it can go and increase up to 30 millicore, not beyond that, because I'm specifying the limit. So this is how you can provide the resources, or you can provide the limits to the pod, okay, within this deployment YAML file. So I hope you understood this part, like why we have to add the resources to the pod. And whatever we have discussed so far till now about the metric server and all those things, is it clear? So this is how you can always go ahead. Okay, okay, not an issue. So if this is clear, so well and good. So we are just adding the resources over here, so that my pod should have certain constraint over the resources. It should not use 100% of the worker node, because from where this is consuming, this all consumed from the worker node, because worker node is allocated, let's say, a 2 CPU at the start while creating the worker node. So the all that CPU that we are giving to the pod, it's from the worker node. So that's where we should be cautious enough, or we should be uh, I mean to say, we should have we should have that 100% confidence that whatever resources we are providing to this resource, or providing to this pod, should be sufficient and should not is like excessive resources. Okay, so let's save this. I think which what all things we have within this, we have this deployment. Let me delete this deployment. So if I delete deployment, replica set will also get deleted and pod will also get deleted. So we are remaining with a service now, which is the default service. So we are good with this. Just now, we have added this extra code over here. Let's try to apply this now. So again, we have created a pod, but this time we have created a pod with resources. Okay, means a deployment internally will create replica set and then pod. So I'm directly saying we have created a pod with these resources. If you want to check what are the resources available to this pod, you can definitely go ahead and describe this. Let's see if I describe this. You will get to see resource section over here, that limits assigned to this and request assigned to this. Okay, we can provide memory related parameter as well, but let's be much simpler at very start. So I have provided the CPU related parameters, and let's say kubectl top pods, just to check the utilization of that pod. So right now uh, we are not sending any request to this pod, so definitely uh, there is no uh, I mean to say, there is no usage of the CPU, because this pod is now idle. We are not sending any requests. So to send any request, let's create a node pod service. Kubectl get pod hyphen show labels. So tier equal to front end over here. Okay, so let's create a node pod service. with this name, my NP service, and some random node port will get generated. So we are creating service to access this pod from the browser. Okay, so let's check which all things got created over here. So we have this pod running, then service we just created this one, which is the port number that we got, then deployment and replica set. So all set over here. Let's try to access this pod, means via this service. So how you are going to access? Get the IP address of this colon this port, service port. Okay, just watch. As of now this is 0 millicore, and let's try to hit that URL. So let's refresh this multiple times. So if you refresh this multiple times, so that many times request will go to pod. Okay, because जितना आप इस URL को hit करोगे, that much time request will go to the pod. So that's where you can see now it is using the 1 millicore. Earlier it was 0 millicore, but right now I can see 1 millicore. So likewise, if you just keep on refreshing this page, keep on hitting this URL multiple times, so that many times request will go to the pod and CPU will get consumed. So it's 2 millicore now. So that is what I wanted to explain, that this pod is consuming 2 millicore now. But what I need, my expectation is, if this pod consumed more than, let's say 30% of the CPU. So let's say 30 or 50, अभी 50% CPU मैं लेता हूँ, and let's say I have a single pod, so 10 millicore. Okay, so 10 millicore से ज़्यादा CPU utilization हो जाता है, in that case automatically it should create new pod. Then again total average CPU utilization will get calculated, and still it is beyond the threshold, again new pod will get created. So who is going to create a new pod for us in case of CPU utilization goes beyond the threshold? That is nothing but HPA. Okay, HPA is one of the resource within the Kubernetes who is going to create this new pod. What is the full form of the HPA? Horizontal pod autoscaling. Okay, as you can understand, autoscaling is a word within that HPA. So autoscaling is nothing but automatically increasing the number of pods and decreasing the number of pods based on the CPU utilization. Okay, so let's go ahead and create the autoscaling uh, with the help of simple command. We have over this, if you go to the Kubernetes section and if you go to the deployment, kubectl autoscale deployment. What is the name of the deployment? Let's say I'm keeping this 30%. Means this is the threshold that I'm keeping, that if the CPU utilization goes beyond 30%, above 30%, in that case increase the number of pods. Okay, and it can increase up to maximum 10 pods. So इंक्रीज करेंगे, लेकिन उसका भी एक लिमिट होना चाहिए कि 100 pod we want to like till 100 pod or till 200 pod we want to increase. So for that matter as well, we have to provide the maximum number of pods it should be auto scaled. Okay, and minimum equal to 1. When it will come into the picture, let's say if the CPU utilization is below threshold is nothing but 30%, which I have defined. So in that case, pod will get deleted automatically. Okay, so as of now I have created this auto scaling. If you do keep settle get all, now you will see one horizontal pod auto scaler object got created, and that object is monitoring, or yeah, that object is like applied over this deployment, my first deployment, and minimum number of pods is 1, maximum is 10, and as of now there is one replica, and we created this a minute back. And this 30% is nothing but a threshold that we have set while creating this auto scaling. And as of now, pod's CPU utilization is 0 because we are not sending any request to this pod currently. Now let's go ahead and hit that URL one few more times, and let's check the kubectl get all. It's still 0%, so it will take some time to get it reflected. Meanwhile, we will just hit this multiple times. Now you can see the 5% over here. So the CPU utilization is now 5%. Okay, 5% of the provided resources to that pod. So if it goes beyond 30%, a new pod will get created. As of now, we have only single pod. So just to simulate this, it's not good thing to execute or refresh this multiple times. What I'm going to do, I'm going to write a shell script which is going to uh, I meant to say which is going to execute this URL multiple times. So let's write a while loop. This loop is going to be infinite loop. I'm not specifying any condition. So this command will be keep on running infinitely. Okay, so let's execute. You can see this is the command which I have written, and it is running in background uh, a lot many times. So if this is executing in background multiple times, and then meanwhile we can monitor the CPU utilization. So it is almost 15%, because with that curl command again I'm sending request to this pod internally. Okay, so that's where this goes 35%. Okay, so once it goes above 30%, it has created a pod just now. You can see the age of the pod is 4 seconds, and this pod got created successfully because the average CPU utilization goes above 30%. Again, the average CPU utilization will get calculated for these two pods, and definitely it will be little bit lesser because there is one more pod to handle the request now. Okay, so let's look for the current status. So it's 17% because now the load is being shared by the two pods. It's 12%, even it is dropping much. So just to get extra request, what I will do, I'm going to write the same thing. So let me make use of the notepad. Okay, what's the URL? What is the current status? It's 15%. Okay, let me run the same, means let me hit to that URL multiple times from multiple terminal, so that it is going to increase the number of requests suddenly, and these two pods will not be able to handle these many requests at a time now. So currently I'm having the 12% of the CPU utilization, average CPU utilization, and as I'm trying to access it from multiple terminal, so the CPU utilization will be increasing now. So it's 15%. It will take some 10 to 15 seconds to go beyond 30%. So we just have to wait and watch. So in real time as well, a request can come from any location. It's from it may be from browser, it may be from I mean to say terminal. So let's say in midnight, suddenly the number of requests comes extra. In that case, there should be some uh, pod auto scaling, so that those extra requests will get handled carefully. So right now I can see this total number of pods are 2, so it should be 3 in a second, because I can see this CPU utilization goes beyond the threshold. So that's where the total number of pods will become 3 in this case, but let's wait till it becomes stable above the 30%. Okay, so I think it's not at stable above 30%. So meanwhile, let me execute this from few more terminals. Let's wait for a moment. This is responding quite slow. By this time we should get 3 ports, but seems this HPA is kind of little slow over here and not detecting the latest traffic. So we just have to keep eye on that and be patient. So it reached to the 30%. Then it needs to go beyond 30% and stable at beyond 30% for certain period of time. Okay, it's still there. Just give me a moment. Okay, suddenly you can see this traffic or the CPU utilization is beyond 30%, which is detected as 52%. Okay, so that's where it has created 2 extra pods for us. So now you understood this concept of pod auto scaling, that if you keep on increasing the number of requests to that pod, then internally metric server is going to monitor the CPU utilization, and if a metric server detects that it is beyond the threshold which is defined over here in the auto scaling, that threshold is let's say 30%, then definitely the number of pod will get increased horizontally matlab a similar kind of pod will get created, and those pods will handle extra requests now on. Okay, so is this clear? So what I will do, I'll just stop all those requests now, and if I close this windows, then in that case this request will get stopped. So in this way, if I let's say close all the window over here, then my CPU utilization of all the pod will become 0, because I will not be sending any request from the outside over here. Let me delete this as well. So I have this single terminal open in which I'm just checking the status of this CPU utilization. I'm not sending any request to these pods via service. So if I do so, then my CPU utilization will get dropped over here because I'm not sending anything. So it is 6%, and gradually it will become 0% as well. Okay, we just have to wait for that moment, and after almost 30 seconds or 1 minute, once it detects that the number of requests becomes 0, in that case this 2% which you can see right now over here, that is the CPU utilization, that will also bring down to 0. So if it is 0, then why do we need these many pods? Okay, if there is no request coming to any of the pod, or if it is very less request coming to the pod, then definitely we don't need this lot many pods over here, because each and every pod is consuming the resources. So if any request is not coming to the pod, then it's okay to delete that pod because that is not being used. So automatically, if it below 30%, then horizontal pod autoscaler is going to delete any of the random pod. It's not something like there is no such rule, okay, this one will get deleted or that one will get deleted. Any of the pod amongst this list will get deleted. Again, uh, again the CPU utilization will get calculated again. If it is found below 30%, again it will get deleted. So till what number of pod it will get deleted? Till the minimum number of pods. So as we have specified a single pod as a minimum, one pod, so there will be at least one pod up and running. Even though if that pod is not getting any request, still that pod will be available over there. So this will take time to delete the number of pods. So I can see totally there are 6 pods over here, and if I check the status now, I'll still see that 6 pods, because this will take some time to delete the pod. It's not something like it will not get deleted. Definitely the 5 pod will get deleted if there is 0% CPU utilization, but to delete that 5 pod automatically, we have to wait for 3 to 4 minutes, then only this will happen. So this is all about I wanted to explain in case of the horizontal pod auto scaling. Okay, I mean there are two types of this auto scaling over here. One is horizontal and one is vertical. Okay, if I talk about in layman language, let's say I have one let's say junior developer, let's say or let's say junior DevOps engineer, and if I want to horizontally auto scale, let's say this junior DevOps engineer is able to handle 10 requests per second. Okay, that means 10 can handle, let's say, at 5 calls in 1 hour. You can consider that. And if the total number of calls become extra, in that case definitely we need to hire few more junior DevOps engineer, right? So likewise, I have just hired one more DevOps engineer, junior one. Again, if these two people are not able to handle the workload, again I have to handle, or again I need to hire new junior DevOps engineer. This is a kind of auto scaling as well. Okay, and this auto scaling we call it as a horizontal one. And what is the vertical auto scaling? Vertical one is nothing but, let's say I have this junior DevOps engineer. Okay, And if I want to scale it vertically, in that case I'm going to hire the senior DevOps engineer. Okay, instead of hiring a lot of junior DevOps engineer, I'm going to hire one senior DevOps engineer, and he's going to handle a lot of work over here. So this will get fired, and as I will be hiring this senior DevOps engineer. But there is one drawback of hiring this one, because he will be a single person who is going to work on all the tasks. What if he is not feeling well, or he is he haven't come to the office? In that case, no one will be there to handle the task, right? But positive thing with the horizontal one is nothing but, let's say if any of the junior DevOps engineer doesn't show up on that day, still we will be having these two junior DevOps engineer to handle the workload. So our workload will not get impacted at all with this kind of a horizontal. So this is a layman language you can consider, like the however whatever we have seen. So till now we have seen the horizontal one. HPA stands for horizontal pod auto scaling, in which the total number of pods will get increased automatically if there is a threshold, if the CPU utilization goes beyond the threshold that we have defined. So same thing I have just explained with this ideology. And in case of this, if I talk about the pod, in case of the virtual vertical auto scaling, in that case, let's say this pod will be having, initially pod gets created with this resource, let's say 20 millicore as request and 30 millicore as limit. Then in case of the vertical auto scaling, the total number of pod will remain only one, but the uh, I mean to say the resources as allocated to this pod will get increased. Okay, so it's not a horizontal. Vertical is like hiring the senior DevOps engineer. In the same way, giving extra resources to this pod instead of creating multiple resources of the same, multiple pods of the same resources. Okay, we will not see the practical of vertical one, because no one uses the vertical pod auto scaling, because that there are lot of constraints that are downside of having this vertical pod auto scaling. So in reality, people mainly choose the horizontal pod auto scaling over the virtual one, over the vertical one. So this is the major difference between the horizontal pod auto scaling and vertical pod auto scaling. If I check the status of all the pods right now, you can see as it is the 0%, so automatically we like all the 5 pods got deleted, and we are left with only a single pod. So everything works automatically over here because of the HPA. If I just describe this, then earlier like it went to 6 pod. Okay, when there was a lot of load, so total pod were 6. Then suddenly we have reduced the load to 0%, so total 3 pods remain from 6, so 3 got deleted. Then 2 pod remain, and at last 1 pod remain. So likewise, this is an history how it happens, and at what time and how much time it took to scale down. And as we are learning everything as under the controller, so deployment is also one of the controller who is going to this increase and decrease the number of pods. Okay, only thing, HPA is going to send the notification to the deployment controller that the CPU utilization goes up, so let's go ahead and increase the number of pods. CPU utilization goes down, so let's go ahead and reduce the number of pods. So such kind of notification internally being sent by the horizontal pod autoscaler to the deployment, and things will automatically taken place. So that level of automation is we can achieve with the help of Kubernetes. So that's where we call this as a container management tool. We don't need to worry about the extra load or the lower load. Automatically things will happen in background. You just have to set it up properly. So that's all I wanted to explain over here. And if you just see the description of this, the strategy type, by default it is the rolling update. This is the one I was talking about earlier. So if I don't define any strategy, so by default rolling update strategy will get taken place over here. So this is what I wanted to show you in this today's section, and in this way we are done with this deployment topic. From tomorrow we may see some other topic. So this was the end-to-end explanation and the demo of this deployment. Any doubts so far over here? Okay, let's wrap it up. I hope each and everything regarding this it's clear now. Thank you so much for joining. See you tomorrow. Take care. Bye bye.